Eckhard Olbrich vom Max-Planck-Institut für Mathematik in den Naturwissenschaften in Leipzig, der heute zu einem spannenden und sehr aktuellen Thema vortragen wird, mit dem wir uns auch immer wieder beschäftigt haben, das Thema Polarisierung, insbesondere in den sozialen Medien. Herr Olbrich wird sich heute ein Medium, Twitter, vornehmen. Ich finde ganz sympathisch, dass Sie es noch Twitter nennen, denn viele assoziieren eher das Positive mit Twitter und das Negative mit X. Und zwar geht es um den Ausmaß der Polarisierung in der deutschen Twitter-Sphäre, und zwar im Zeitraum von 2021 bis 2023. Die Studie, die uns heute vorgestellt wird, wie man schon dieser ersten Folie entnehmen kann, ist aus einer Kooperation mit zwei weiteren Autoren entstanden, Herrn Gurnacki und Herrn Geis-Bauer. Ansonsten kann ich auch noch ergänzen, dass Herr Olbrich kein Unbekannter hier in der TU Dresden, weil Sie, wenn ich richtig informiert bin, auch hier studiert haben, bis 1990 Physik an der TU Dresden. Insofern ist das ein Stück weit auch eine Rückkehr.
Ja.
Herr Olbrich, wir freuen uns auf Ihren Vortrag. Sie haben heute das Wort.
Yeah, so we agreed that I talk in English. Okay, yeah, great. You could also ask in German if you want, and you can interrupt me at any point if something is unclear or so. I think we have enough time that we can do that. So I'm very happy to have this opportunity to present my work here to political scientists. So that's so I'm not a political scientist, obviously. So I'm a physicist working in a mathematics institute, doing, I would say, computational social science. So it's this new emerging field. Coming, so to say, also from this more general complex systems community myself. So, and the work that I will present is joint work with Armin Polacky and Felix Geisbauer. So Armin Polacky is a PhD student. He's doing a joint PhD between our institute, so in Leipzig, and Sciences Po in Paris. So that's also called cocktail. So we'll get 2 degrees. So the work that I will present is, for a large part, will be part of the FS PhD thesis, and Felix Geisbauer was a PhD student in our institute and is now a postdoc at the Weizenbaum Institute in Berlin. And they are both involved in this work. And the work that we're doing in computational social science in Leipzig is part of a European project. It's already the second one. So the first one was called Odysseus. So it's Binder Dynamics and Cultural Conflict European Spaces. And it was the main idea there was already somehow that with the rise of digital media, it's somehow not possible anymore somehow to get a full picture of what is discussed in the public sphere by just, so to say, reading what you can get. So you need new methods to analyze these contents and the dynamics that can be observed there. And this was somehow the starting point. So in the Odysseus project, we somehow developed methods, tools, general ideas how one can do that. And now in this Social Media for Democracy project, we are more interested now also in looking on the impact. So basically the first one was more about the observations, and now it's also more about understanding mechanisms and causal effects. And this is somehow the partners that we have in this project. So it's just to show you somehow that it's a highly interdisciplinary project. So we have a lot of different disciplines there. We as a mathematics institute are more somehow for the methodological side, for the modeling side, and also for the methods for the data analysis. So Max Planck Society is also involved via the Max Planck Institute for Human Development. So that's more psychology. They will do also experiments. And there's also political science, so it's that's the democracy theory part. It's Pavel Kowalewski. I don't know if you know him from Leipzig. Yeah, that's just to give you somehow a big kind of picture what the context of the work is that I represent. So one of the topics that we want to study in this project is polarization, because in the public discourse, including also the scientific discourse, is often increasing polarization is first, so to say, a diagnosis of in different contexts, different ways how it is measured as a statement, basically, that people say, okay, polarization is increasing. And second, social media are often made responsible for this. And to some extent, what we want to do also on the project is, first of all, also to provide, so to say, empirical evidence for both statements, or somehow also find counter evidence if it's not true. And so that's so to say the overarching one of the overarching topics. So polarization is only one dimension on which we want to study the impact of social media. So we also identified two other dimensions. So one is participation. So that's basically the dimension where mainly people discuss it. Social media has more the positive effects, because somehow it lowers the thresholds for participating in public discourse and offered new channels for interactions. And the third one is trust, in particular in democratic institutions. So that are the three dimensions that we want to study. Polarization is one of them, and today I want to talk about polarization. And I want particularly discuss polarization on Twitter. So why Twitter? So Twitter is, I would say, still one of the most relevant social media platforms for political information, in particular with respect to reactions on events in real time. And it was the platform where a lot of politicians and also particularly journalists and media were active and somehow got, so to say, their news. And somehow in the project, we looked somehow on the number of followers for several media, so selected media. So you see here, so to say, so on the left side, so to say, two newspapers, and we have a tabloid, we have TV shows, and we have also alternative media, and on the with the Heute show also some more comedy satirical show. And you see here, if you look at the follower numbers, that Twitter is still, so to say, one of the important one. In particular, if you compare it with the other micro-blogging platforms, so the newer one like Blue Sky, Mastodon, Telegram, or Threads, then you see basically the others are somehow have not yet achieved, so to say, a significant following. You see also the three are, so basically the three main players here are still, it's now X, Instagram, and Facebook. But Instagram and Facebook have a different character than X. And so I would say that still shows from the follower numbers that's still important, but the follower numbers is somehow also a historical number, because people, so to say, it's usually increasing, and it's not, as unfollowing is much less likely than following. Even if you are not active anymore on a platform, you still are following an account. So that's so to say a very superficial metric for measuring, to say, this kind of impact. But it was so that's why, so to say, we need also better measurement for that. But it still gives you somehow an impression that, so to say, these new platforms are not having are in no way, so to say, of comparable importance than Twitter. But so to say, a lot of there is some movement of leaving X, so to say, because of the change with the takeover by Elon Musk, and so also some of the big media platforms are leaving Twitter, and that's the example of the ZDF. So in March this year, so they also not really closed, so the account is still there, but somehow they announced that they will not be active anymore on Twitter. So that's my summary here. So one has to say that the study that I will present is in this sense already historical, because you cannot do this kind of analysis anymore on X now, because the research API that was used for that, so the way how we collected the data is not open anymore. Now they have an API which, with the research API, you could collect 10 million tweets per month without any payment. And now I think you have to pay $300 for 10,000 tweets in a month or something like that. So it's and to do it somehow on the same scale that we did it before, you cannot pay it. You need somehow then perhaps special agreements with Elon Musk. So now with the DSA, Twitter has to provide data to researchers, but and they have already a form and several people already applied, but so far almost no one got approved. So that's still unclear to which extent this way will be accessible in the future. The same applies to all the other platforms. For instance, for Instagram and Facebook, so Meta, they had CrowdTangle as a platform where you could collect data. They closed CrowdTangle, so in August it will be closed. Now they have also this form for this DSA, so to say, compatible form, but it's also totally unclear to which extent it will be possible in the future to get the data. At the moment, the best way, the most interesting platform with respect to data accessibility would be TikTok. Maybe because they try to improve their image or somehow to avoid, so to say, harsh regulations, also as a reaction to what happens in the US. I'm not sure. I'm also not sure how reliable it will be and how long this will last, but that's at least at the moment something like that. And it's interesting because it's a platform of increasing importance also. Okay, for this talk I will look on Twitter. So we call it Twitter because in this time span where we analyzed it was still Twitter. So we want to ask the following questions. So first of all, we want to look what are the main issues that are discussed, that basically were trending topics in Germany on Twitter. Then we want to see to which extent they were polarized, the discussion was polarized. And then we want to see what kind of different, so to say, user types we have and to which extent they are polarized. And finally, we want to see how aligned is this polarization. So we have different topics, and these topics we might observe polarization, and then we want to see to which extent the same users are always on the same sides with respect to these topics. So this is related also to something what I did in a different context where I wanted to construct from data political spaces. So my original idea to do this kind of analysis was that I could somehow get basically for the different topics, you might get different dimensions of a political space, and then we can also see, so to say, build a political space of the German Twitter sphere, and we will see to which extent this is possible or not. The last question, this issue alignment, is related to also work that you did and also that Steffen Mau did, and sound very prominent in his book Triggerpunkte. But here, what I found most interesting was this paper from 2022, so where they studied European social survey data, and where they basically used items from the survey to construct these 4 dimensions, so dimension of migration, climate, crisis, and gender issues, and also an economic dimension. And what they basically found that they form independent factors, so that they are not strongly correlated. As they found some weak correlation between 2 factors, I think, but it was mainly that they are somehow uncorrelated, that basically he did not find issue alignment with respect to these issues. And if I remember correctly what I heard from Mike Herald's talk, you also had a similar finding in your data, that somehow if you do it in the general public surveys, that it seems to be that the attitudes on these different dimensions are not aligned. And so I found it interesting to see, okay, what do we see then if you look on Twitter? And so what did we do? So we looked at, here you see basically this interface from Twitter, and there you see on the right hand side this trend. So basically that's Twitter, they also always are listing, so to say, what are the trending topics. And this, and we check this, I think, every hour over a day, and then we look which of these topics are most often listed there. There are also sometimes numbers put in, but these numbers were not reliable, we found, so we did not use these numbers. So how many tweets? So because one could also think about, let's take the most important one, so with the highest numbers, but we found that it's not reliable. These numbers did not reported there, so we somehow looked at which trends occur most often, and then we selected the 5 most important ones, and for them we on the evening of the next day, we collected data for 2 days to the past, so that we somehow get this day and also the next day, so the day where it was trending and the next day. So that is basically the time window on which we collected the data for 5 trends per day. Okay, obviously there are shortcomings with this kind of sampling method, but as our impression is that it gives already a quite good overall impression. So that's basically how this data look like. So you see the number of tweets over time. You see there is a gap there. There was, so to say, we had a technical problem in 1 month, so we have this is missing. So you see somehow the order of magnitude of what kind of data we collected here. And here you see main topics. This is also somehow taken with a grain of salt. There is some arbitrariness here. What I did here was I computed a topic model, so an LGA model with 60 topics, and then I aggregated these topics further into 22, so to say overall themes or topics. We did also different topic models. We also used bird topics, so that's already this transformer-based topic model, where you can, as here, I basically used all the original tweets from one trend as a document. And in the other one, we could look at the topics for a single tweet. With the LDA, you get a probabilistic topic model, so basically you get a probability for a topic for your document. With bird topic, you assign basically a single topic to your document, which is for a single tweet. You could say, okay, that's probably true, but as it turned out, it might be more difficult. For instance, we have trends here about there was this soccer game between Hungary and Germany, and where basically the Allianz Arena in Munich was illuminated with rainbow colors. And so basically it was then a discussion about this trans issues and then also things and whether the national team in Germany is too woke or whatever. So this kind of thing. So it is sport related, but it's also politics related. So it's already more than one topic. So one has to be careful with this kind of topic assignments. But what I also did was somehow I used the topic probabilities to cluster the trends. And that's now a dimension reduction technique for the visualization of this of the clusters. And you see basically what I got here. Somehow I got 6-5 clusters, so the one you can forget. So these are somehow still foreign language trends that were collected by. This happens when you have a search term that has, so to say, different meanings, like different languages. For instance, there was, for instance, Hardel. So this is German as German word. What is the English word for Hardel? But there's also an NBA player with the same name, so Hegel. And you get it, and if you use this search term, then you get a lot of tweets about this NBA player. And I think the trend was related to the weather phenomenon, but not to the NBA player. But so this all somehow this ambiguity. So you can forget that. But you get what is interesting here. So to say the five big other clusters in particular, 3 and 5. These are unpolitical. Or 3, I said already, could be political. So this is sports. 5, that is something I call it here greetings holiday. So that's it's about Christmas, about Easter, and it's about people just saying good morning to each other on Twitter, such kind of things. Start of the week is usually trending every week, this kind of things. So gives you a big, and then you have a big cluster about the Russian aggression of Ukraine. So that obviously created a lot of trends on Twitter, and you have COVID. And then you have what I call mixed political topics, and we will see more about that later. So that's already somehow giving you a big impression. And now I come to the point how we analyze the data. So obviously one could somehow now do a content analysis, but that's for the social media data there is somehow established a simpler way to look whether something is polarized or not, and that's looking at the sharing behavior of the users. So what kind of of information is shared. So on Twitter, it was retweeted. And it is now already established, and this I think is the seminal paper here by Konova in 2011, that if you look at clusters in the retweet network, that these clusters were very often correspond, that you can somehow interpret them as homophilic clusters. So basically that you share content that is somehow close to yourself. And if you have a political debate, then it's related to your political stance. It can be also different. For instance, if you have tweets with a search term with a lot of different languages or same language but different countries, then the clusters can also correspond to languages or countries. Like if you have the English search term, then you get something for India, Australia, and other countries. But here it was shown for the US, for Democrats and Republicans, that basically the clusters in the retweet network correspond to the political stance of the accounts. And these are two other examples with data that we collected. So on the left-hand side, you see already a highly aggregated retweet network collected with the keyword Brexit in 2019. The colors are there, the community also that you get by modularity maximization, and you see basically on the right-hand side the Brexiteers, on the left-hand side the other side. So you see Boris Johnson, there is Corbyn, but a lot of other politicians. But on the right-hand side, you see an example from Saxony. So this was collected before the last elections here in 2019. So over a longer time, this was not collected with a keyword, but there we basically did use the snowball sampling to collect data as a set of, I think, 250 around accounts where we basically collected all their tweets and all retweets and all replies on these accounts. And this allowed us to construct the retweet networks, but also to construct reply networks, for instance. So that's the actual discussion step. And there you see basically, again, as we are here in Saxony, usually we know some of the names. You see again this polarization into a more leftish cluster and clearly a right-wing cluster. And you see also Christian Democrats, for instance, somehow in the middle.
Focus, go on. Well.
Yeah, there is another Felix Geisbauer, so that's if you see. So here you see again. So that's again on the top. You see again the retweet network. So one that we have seen before, but the other one is not. It's not about the elections, but it was on New Year's Eve, 2019, 2020. There were some kind of not real riots, but there was some violence in Konnewitz in Leipzig, and then there was a discussion who is responsible for that, and to which extent the behavior of the police was right or wrong. And there you see again the same kind of structure in the retweet networks. And just to compare, what you see on the bottom are the reply networks. Basically, there you have a link if one account replies on another. And there you don't see, as the colors correspond to the colors from the retweet networks. But there you see that you don't get divided clusters, because basically there you have as people reply on content from the other side. But usually they don't share it. So that's basically the main distinction. And we use then this distinction now to do the analysis for the retweet networks in our data set. So we have such a pipeline. So we create the retweet network based on the German tweets collected for a trend. Then we select the largest retweet connected component. So there might be somehow accounts that form very small networks that are not connected to the rest. So we want to have the large connected component. We do what's called soft aggregation by removing all accounts that would feed only a single account, somehow to reduce the computational burden that we have to do for the further analysis. And then we considered only retweet networks having not less than 50 nodes, because of course otherwise this clustering is not very reliable statistically. And it's basically we ended with this 1953 trends. And then we calculated the clusters by doing a stochastic block model and asking whether it's one or two clusters. And then we used the force-directed layouts, and this corresponds to the pictures that I have shown before to make the model selection. So if you are interested in these technical mathematical details, I'm happy to talk about it more, but maybe
we come back to it later.
Yes. So Okay, that's just to say this is for this were the last in the collection. So for the last days on the left side you see basically the different networks that you get out of that. On the right hand side you see the colors somehow that basically identify them the clusters. It's just to give you an impression how different this kind of networks then look like, and basically about the variability that we see then in these networks, and to have, so to say, an idea what is underlying, so to say, this summarizing statistics that we do there. Okay, first question that you can ask is basically, I called it here polarized versus unpolarized trends, which means retweet network has only one cluster or two clusters. So you see it's almost, so to say, the same type of numbers of friends. So here it's just using the keyword and doing a word cloud where the bigger words, so to say, are the more often appearing words, and the smaller ones least often. You see then that there are also political terms in the unpolarized, and the reason for that is sometimes to a certain topic only, so to say, one chem is tweeted. So, and the others are, or if there's only one account or two accounts that somehow also from the other side, then it's not recognized as a cluster. So it's not exactly clear. For that, basically, we need also to do additionally to the analysis that I present today, the content analysis, but that it's not yet finished. But nevertheless, you see already, so to say, you see here some kind of weather phenomena on the left side, but also DFB-Pokal, Fußball, so some sports. And on the other side, you see in particular also a lot of trends that are related to media, talk shows and these kind of things. So basically, you see then already why talk shows are as they are, so that they are somehow designed in order to generate a resonance or outrage on the media, in particular on social media. So that's basically reflected here, that it works. This kind of design, one can question whether this design is, so to say, useful for improving deliberation, but at least it creates tension and it creates a polarized debate on Twitter. So now we can ask how aligned are these polarized trends. And for that, we can distinguish between two types of alignment, or we distinguish user alignment and trend alignment. User alignment means just I take the accounts and I take pairs of accounts and I ask to which extent they appear in the same cluster over the trends on which they appear both. That's, so to say, the simplest one. The simpler one, the second one would be somehow I look to which extent these two clusters that I see, if I have trends with two clusters, and to which extent the two clusters that I see are somehow the same in two different trends. And the problem there is that it might be not the same users that are tweeting in these different trends. And so I have first to ask to which extent, so to say, there is a joint user set, and then I can look to which extent these users are in the same clusters. So let's first look for the first one. What did we for the first? That's somehow easy. So we take pair of users and then we go to the trends in which they occur both. And then we say, okay, +1 if they are on the same cluster, -1 if they are not in the same cluster, and then sum it up. If they would be randomly assigned to a cluster, then it would be, the expectation value would be 0. So that means a high number would mean they are always in the same cluster. A low number would mean they are always not in the same cluster. And now, okay, we doing it for all the users might be not the best idea. So first we try to get an idea what kind of users do we have in the data set. And for that, we looked in particular, also on the one hand side, we looked on the number of trends. So how many trends is this user, appears this user or this account in the retweet network? So that's the x-axis. And on the y-axis, I have here two things. So that is one in the retweet network, the in degree and the out degree. The in degree means how often is this account retweeted? And here we sum it up over the trends. And the out degree means how often is this account retweeted? And what you would expect here, if it would be somehow just some normal distribution, so to say, of this properties, you would expect that the number that basically this in degree, so the number how often an account gets retweeted, and also the out degree would be a linear function of the number of threads. So in the more retweet network it occurs, the higher should be this in degree. And so you see, okay, for the in degree, it's there is no trend at all. So, but you see here the yellow one, the yellow dots are the accounts, the 200 most retweeted accounts. And you see basically, okay, they are on top of this distribution. That it's not so surprising. You see also that they are on the right side. You see they are not very much retweeting, so they are mainly broadcasting, mainly sending, but not resending other stuff. For media accounts, this is somehow natural, but we will see in a moment that it's not classical media accounts for only these accounts. But you see also that there are only very few that get very often retweeted. So you see it's a very small number there. While even more interesting picture is on the right side. So there you see that this blue, so to say, the normal users, there you see more or less a linear increase with the number of trends of the article. But the accounts that are in mode, that have the highest number of trends in which they appear, they also retweet much more often than you would expect with this linear increase. And the numbers are here already somehow, some of these accounts, they several hundred tweets per day they do retweet. So, okay, probably your first idea would be these are bots or automated accounts, but it's not so clear. So some of them are very, very likely not bots because they show somehow more the natural behavior. Some of them are at least could be somehow what's also called inauthentic accounts, which means it's not necessarily bots, but it could be several persons that are somehow semi-algorithmically working, so that they're using certain lists, which kind of accounts are retweeted also. So that's very difficult to assess. But what one could somehow already think about it, about the causality. So because, as you would say here, okay, they are much more retweeting, so the accounts that appear on most of the trends are much more retweeting. So you could somehow thinking about perhaps these accounts might be at least partially responsible for this topic be a trend. So because these accounts, they are accounts that are come out very heavily retweeting content, that they somehow are able to some extent creating a trend. I have not yet a clear idea how one could test that, but except somehow at least we can build a model where we can somehow at least test to which extent this is possible. But that's at least a hypothesis that one can get from this data. So now let's look at the user alignment. So somehow for the usability, I showed here the picture for only for 20 accounts, so basically the top 20 accounts. So these are the top 20 most retweeted accounts and the top 20 most retweeting accounts. And when you take one account and then basically you order this the accounts according to their user alignment, and then you plot all the other accounts, and then you see these two clusters. So that it's quite obvious that you get two clusters. And if you on the right hand side, you probably will not know this the names, because these are thin accounts that are retweeting. But on the left side, one know the names, some of them at least. And then basically you see on the top the smaller cluster. This is more a left-wing cluster. So this is Volksverpetzer, Anonymous Germany, the Postillon, ZDF Heute Show. But you see also these are not classical media accounts, so these are more entertainment, satire, comedy kind of accounts. But the bigger cluster here is the right-wing one. So there you see AfD politicians. You see also Stefan Homburg. So this is one of the, so to say, the most prominent Querdenker. And you see also everyone who somehow is active on or was active on Twitter might recognize the accounts. So as soon as you look at some of these topics, and but they are not institutional. So like Annabelle Schunke or Tom Bowen also. But Julian Reichel is also there. So and you see also here in the middle. So Sarah Wagenknecht in this data set, so to say, she's not aligned with either of the two clusters. So she is here in the middle. And this is on the left side. On the right hand side, you see there's also one account which is not aligned with both So this is a bot. It's not existing anymore, but it existed in the time when we collected data. Bundestag tweets. So basically a bot that retweets all tweets from the members of the parliament. And
which one? The
Bundestag tweets. So on the right side,
Yeah, right.
the not aligned one. So he is somehow aligned with both sides. So that makes sense. So okay, what we see here is that and if you look at the top 50 or even the top 200, you see a similar picture. That if you look at the user alignment, we get basically two clusters, a left and a right cluster, and also that the left is smaller than the right. So that's a coherent picture, and you see the difference is bigger on the influencer side. So it means on the most retweeted accounts side than on the retweeting accounts. So so that is somehow the defining number one. Now we can also look at the trend alignment, and there basically. If we have already looked with what is the users, the joint user set for our two trends, then basically it boils down to comparing two partitions of a set. To which extent these two partitions are similar, and then there exists a measure called the Wand index, which is doing that. And so it's written how it basically you count all pairs between accounts, and then you look to say to which extent they are in the same subset in your both trends, to which extent they are both in different subsets. So this would be somehow aligned pairs. And then you would have the others, they are not aligned. So, and you count basically the ratio between the aligned pairs to the unaligned pairs. So now the problem is if you do somehow random partitions, two random partitions, and you compare them, then you also would have some kind of alignment between the two. And now you want to get an idea, so to say, what would be a significant alignment. And for that, somehow you correct for random alignment by taking a null model, and the most used null model here is basically you commute all your accounts. You subtract the expectation value for this null model of this rand index. And then you calculate this adjusted rand score to calculate the alignment. And that's what I used. And what I then did was somehow I used my topic model somehow to select trends according to different topical dimensions. And I used somehow with topical dimensions that are similar to the dimensions that were also studied by Stefan Mao et al. In this paper. But I also included COVID and Ukraine because these were these big selected clusters when I had this overview on the general topics of my data. And you see also in this histogram there the number of trends that go into this calculation here for the alignment. You see also for the gender it's relatively small, so that is somehow. And it's easier to get a high alignment for a small number of trends. Of course, then you have also high user alignment. So the more yellow colors here are these high alignments, blue ones are low alignment. Now, what you see here is you get, so to say, one big cluster again. So that means COVID, climate, migration, gender are somehow aligned with each other. Migration might be the most, so to say, as the least aligned topic, so it's also a relatively slow number of trends. So that's I plan to do somehow a more detailed analysis for this issue here. At the moment, I cannot say so much more about it than what you see here on this figure. But you see basically these four topics are aligned, while the Ukraine somehow forms an own cluster. But what we do not see is basically that we get this different on this interfigure climate, migration, gender. We don't get this independent dimensions that were observed in surveys. And so the next question now is somehow to explain that. So because there are different possibilities, how you can explain that on Twitter, but basically that's the finding. This is just to show you basically for Ukraine, COVID, and as comparison climate, which is a bit difficult to see here as the orange ones. It was just somehow to see to which extent this these topics were discussed, say, over time. You see in particular that COVID it's still active, so to say, and was somehow, at the beginning, the dominant one. So that's just a summary of the findings, and we see still that we have something to do. In particular, also the dynamic aspects. I somehow, at the moment, I analyze these 2 years somehow as one big, say, block, as altogether. Obviously, one could expect that something happens there. It would be also interesting to see what happened after the mask took over, because it was somehow in autumn 22, I think. So we have still data also afterwards. We see also something there, but we have not yet systematically looked at that. That would be something interesting. And it would be also interesting to get feedback from you, for instance, about certain topics or so that might be worth to look more closely in this kind of data set, because I think it's a quite rich data set. That's it's probably much more what one can learn from that. Okay, so that's look.